dot product or inner product of two vectors. We note this product as A dot B or using these two brackets. This notation using these two brackets is old notation and it's not so used right now. For any two vectors, v1, v2, we define the dot product as the real number obtained by taking the real number x1 times x2 plus the real number y1 times the real number y2 plus z1, z2. For example, let's write an exercise. Find 3i minus j dot product I plus 2j minus k. So x times x is 3 times 1, 3, y times y minus 2, z times z 0. So the final answer is 1. Theorem. For any two vectors AB, the dot product equals to length A times length B times cosine theta between A and B. Let's suppose that AI plus J be 5I minus plus 10J minus 10. Find cosine theta between A and B. So let's go back to the last formula. So from this formula, you can write the cosine theta between A and B equals to dot product divided by length A times length B. So this is correct if the vector A is not 0 and the vector B is not the vector 0. So the lengths are not 0. So I can divide because these two terms are not 0. So I will use this formula. So here cosine theta between A and B is equal to length A times length dot product over length. So dot product A times B over length A times length B. So let's calculate each term here. What is A times B dot product? X by X, it's 5, Y by Y plus 10, Z by Z 0 over length A, it's root 2 plus length B times length B, it's root. How to calculate length B? Length B equal length. I can take 5 outside. 5 outside length I plus 2j minus 2k. So this length is root 1 power 2 plus 2 power 2 plus 2 power 2. So it's root 9, which is 3. So 3 by 5. So the answer here is 15 over root 2 times 15. So it's 1 over root 2. So it's root 2 over 2. So what is theta between A and B? It's pi over 4. Remark, if the length of the vector A is 1, then length A, then dot product AB equals length B times 1, which is length A, times cosine theta between A and B. But if you suppose that theta here between A and B, so what is cosine theta? Cosine theta, it's this part, this length from here to here. Let's suppose that this length is L. So it's L over length B. So L equal length B times cosine theta. So this answer here is L And this is equal also to the dot product A times B. In absolute value, I suppose here theta less than 90, so it's positive. So always this length, I will sketch it in red, the length L. So this length L is the projection of the vector B on the vector A is equal to the absolute value of dot product AB, because A of length 1. So this property is correct only if the length of the vector A is 1. So remarks. If the vector A is orthogonal to the vector B or perpendicular, then the dot product will be 0. This is equivalent. Why this is correct? If we suppose that this side is correct, if we suppose that the dot product is 0, so I will suppose that then the dot product is length A times length B times cosine theta, but length A is not 0 and length B is not 0. I suppose the vectors are not 0. If they are 0, the vector 0 is orthogonal to any another vector because it's in any direction. Okay, so if it's not 0, if I suppose length A, length B is not 0, so cosine theta is 0. Sine theta 0 means theta will be pi over 2 or 3 pi over 2. So this means that A orthogonal to B. The inverse will be the same. If I suppose they are orthogonal, so theta is pi over 2, cosine theta 0. So if I write here, this is 0 times anything, so A dot B will be 0. Remark number 2. The dot product of A times A by A will be length A power 2, because here I have cosine 0. Theta between A and A is 0. Cosine 0 is 1. Now here I have property number 3, remark number 3. I have the property of distribution of dot product on the addition of vectors. So it's the same property of distribution of number. It's also correct here. In fact, to prove that, if you suppose the vector B is xb times I plus yb times j, and here vector C is xc times I plus yc times j. So what is the addition of these two vectors? Will be x, the addition will be xb plus xc times I plus etc. If I suppose the vector A is xa times I, so now what is the, how to product? I will take the number xa times this number, so it will be xa times xb plus xc plus etc. So if I continue, it will be xa times xb plus xa times xc plus etc. So like this, I can prove that always I will have xa times xb exists here, and xa times xc exists here. Okay. Remark number 4, unit vector I dot product unit vector G will be 0, because this is correct, because I orthogonal to J. The same for the others here. I orthogonal to K, J orthogonal to K. But if I take I and I, the dot product will be length I power 2, so it's 1. Also for J, also for K. We can use this method to solve an exercise like this. So we can solve this exercise in 2 methods. Method number 1, using the definition. 1 by 2, 2. Minus 1 by 3, minus 3. So the final answer is minus 1. Method 2, you can use the last remark here, this remark, number 4. So here I will take I times j. I will use this remark and also the remark number 3 of distribution. So this is 0. This product I by j, it's 0. I by k, it's also 0. Minus 1j times 2j, so it's minus 2. J by j, it's 1. Then after that, minus 1j times 3k, it's 0. So the final answer is minus 2. Where is the mistake? Let's repeat. So here I have 2. Wait a minute. So here in the method 1, there is a mistake. Let's correct it. So here I will take x by x. Where is the x here? The x here is 1, and x here, no x. So it's 1 by 0 plus. Here there is minus 1 times 2, minus 1 times 2 plus. There is no k here, 0 times 3. So the final answer, minus 2, the same answer. Unit vector. The unit vector of any vector A is by definition the vector lambda times A, vector A, where lambda here is given by 1 over length A. So I suppose that the vector A is not 0, is not the vector 0. So I can divide by length of A. So I will use this notation for the unit vector of the vector A. So what is the length of this vector? Remember that we have property that lambda A length equal absolute value of lambda times length A. So it will be absolute value of 1 over length A, it's 1 over length A because this is positive, times length A. So the final answer is 1. So this vector of length 1. Exercise. Find the unit vector of the vector 7i minus 4j plus 4k. So let's calculate the length of A, which is by definition root of 7 power 2, 49, plus 4 over 2, 16, plus 16. So it will be root of 49 plus 32. So 50 plus 31, so 81, root 81. So it's 9. So let's calculate now unit vector of A will be 1 over 9 times, let's repeat the formula at first, then we will write the numbers. So it's 1 over length A times vector A. So it's 1 over 9 times the vector 7i minus 4j plus 4k. So we can write the final answer like this: 7 over 9i minus 4 over 9j plus 4 over 9k. And you can verify in the last here that the length of this vector will be 1. Projection vector. Now the projection vector of the vector B on the vector A. Here, vector B is given here in black and vector A in blue. So the projection vector is the red vector. So it's the same as the projection of vector B on the unit vector of A. So remember that this length from here to here, it's the product of B by the length of, it's the inner product, wait a minute, without length, the inner product of B times unit vector of A. And this is correct because this theta is less than 90 degrees. If it's bigger, I will take absolute value. Okay, so this length, I will product it by the unit vector of, so the unit vector of A, not B, the unit vector of A. Okay, so let's write more details. So it's equal to B times this vector, it's the vector A divided by length of A times here vector A divided by length of vector A. So we can write the last answer. It's B times A, the product, inner product of the vectors over the length of A power 2, and this real number produced by lambda. This is as lambda times vector. Exercise, find the projection vector of B on A. So let's calculate length A. What is the answer? It's root 4 plus 1 plus 4, root 9 is 3. What is length B? It's length vector B. It's root 49 plus 16 plus 16, 32. So root 81. So it's 9. What is A inner product B? It's 7 by 2 here. Here 7 by 2, 14. And 4 by minus 1, minus 4. Then minus 4 times minus 2 plus 8. So the final answer is 18. So let's go back to our formula. The projection is given here by this formula. So the projection of B on A is given by the inner product AB over length A power 2 times vector A. So it will be 18 over, what is length A? 3. 3 power 2, 9 times vector A. So it will be 2A. So the final answer, 2 times A. So let's product A by 2, 4I minus 2J minus 4K. The last exercise, let A I minus J plus 5K be 2I minus 3J minus K. Is A orthogonal to B? If the inner product is 0, so they are orthogonal. So let's calculate the inner product. So let's calculate, take 1 by 2, here 1, here 2, it's 2, minus 1 by minus 3 plus 3, 5 times minus 1 minus 5. So the final answer is 0. So A, the vector A is orthogonal to the vector B.